Indirect collisions type 3, angle between directions of motion. So here in 2005 we have two spheres moving towards each other. And we have to be careful with this one because we can see A and B are approaching from the left and from the right. And what it's asking us to do first is find the speed of the sphere after the collision. So the same as before, we're going to set up our principle of conservation of momentum, Newton's experimental law of restitution, and then solve our simultaneous equations. And the second part of the question, which I'm interested in, is the fact that it's asking us to show that the collision afterwards, that the angle between the directions of motion is given by tan inverse of 4/3. Okay, so we're going to start by setting up our table. And to do this, I'm going to just add in the diagram. So we can see here, obviously, that if A is approaching from the left, then we have its J vector is in the positive direction, and its I vector is also in the positive direction. So if the angle is 45 degrees, then that's our opposite, and that's our adjacent. So again, we'll have our U sine alpha, which will be in the J direction, and then this will be U cos alpha in the I direction. Whereas for B, we can see that when it's approaching from the right-hand side, again, we have our J direction is positive. But we have to be careful here because we can see our I direction is actually negative. Okay, so again, if this is the angle 45 degrees, there's 90, and that's our opposite and our adjacent. Well, again, we're going to have the opposite, so that'll be U sine alpha, which will be in the J direction, and U cos alpha in the I direction. So again, it's important to note here that we can see after the collisions, if they move off in some sort of a direction, say like so, and if this one moves off maybe in this direction, then if we were looking at their vectors in the I and J direction afterwards, what you'll notice is actually that the I is changing direction, but the J is staying the same. The I is changing direction, and the J is staying the same, right? And that's why we're always saying in this case that J is conserved. And if we notice that the line of centres is in the I direction, so that's the one that's going to change. So when the line of centres is in the J direction, it would be I that's conserved. And when the line of centres is in the I direction, it's the J that's conserved. Okay, so let's make out our table. Okay, so filling it in then, if I call the first spheres we're calling A and the second sphere we're calling B. So for A we can see that it's U cos alpha I and U sine alpha J. So in other words, U is equal to U cos alpha I, U sine alpha J. But of course, alpha in both cases here is going to be 45 degrees. So therefore, if we get cos 45 for both sphere A and B and sine 45 for both sphere A and B, well, it's going to be 1/√2 in both cases. So therefore, subbing in to the equation there for our initial velocity, we have U over √2 in the I direction plus U over √2 in the J direction. We are told in the question that mass M for sphere A, and it's an identical smooth sphere B. That means their size and shape and mass is the same, so it's M for both cases. So afterwards, because their line of centres is through the I, we said that J was going to be conserved. So the velocity for the I direction is changing, so we call that P. And then we have U over √2 for J. And we have to be careful here for B because we identified that the I direction is actually to the left, in other words, in the negative direction. So that's going to be minus U over √2I. So how many of you got that right? Hopefully all of you. And then afterwards for B, we'll have Q, and of course J is conserved, so that's U over √2 for J. Okay, so now we have our table made out. We're going to do our equations. So we'll have principal conservation of momentum. So m1u1 plus m2u2 is equal to m1v1 and m2v2. So subbing in our values, we have m by u over root 2 plus m by minus u over root 2 is equal to m by p plus m by q. So dividing across by our m's there gives us p plus q is equal to 0. So in other words, p is equal to minus q. And then we also have our Newton's experimental law of restitution. And again, we know that these are all on page 51 of our maths tables. So we have V1 minus P2 equals minus E U1 minus U2. So if I'm subbing in there, we have P minus Q is equal to minus E times U over root 2. And then it's minus u over root 2. So therefore that simplifies down then to give us minus E times 2u over root 2. So P minus Q is equal to minus 2eu all over root 2. So that's our second equation there. Okay, so of course we can say P is equal to minus Q and sub into the second equation, or set up your simultaneous equations. It's all the same. So I'm going to say P equals minus Q. So if I sub 1 into 2 straight off, then I have minus Q is equal to minus TE 2EU over root 2. So therefore I have minus 2q. So in other words, dividing both sides across by 2, minus 2 gives us q is equal to EU over root 2. And of course, P equals Q. P equals minus Q, I should say, sorry. So therefore P is equal to minus EU over root 2. Okay, so now we have our velocities after. Well, what we need to do next then is find the speed. Now you have to be careful here, right? Because it doesn't say find the velocities, it says find the speed. So the speed means we have to find the magnitude. So we have to find the resultant of our velocities afterwards. So let's line up our two velocities. So what do we have for A? Well, A's velocity afterwards, V1, is equal to minus EU over root 2I plus U over root 2J. So therefore, if I want the magnitude, I need to get the square root of A squared plus B squared. So therefore that's going to be the square root of minus EU over root 2 squared plus U over root 2 squared. And therefore, if I square that out, that gives me E squared U squared over 2 plus U squared over 2. And therefore I have U squared is common. And if I take out U squared over 2, well, that leaves me with E squared plus 1. And I can leave it like that, or I could take out the U squared over 2, which would be U over root 2 times the square root of E squared plus 1. Okay, so that would be the velocity for A. And then we want to do the velocity, sorry, that should be the speed, I should say. So our speed is our magnitude. And then we do the same for B. Well, V2 is equal to EU over root 2 in the I direction plus U over root 2 in the J direction. So again, if I get the magnitude using the same formula, I'm going to have the square root of EU over root 2 to be squared plus U over root 2 to be squared. So essentially, once I square my EU, I'm actually going to end up with exactly the same thing, because obviously squaring a negative and squaring a positive is going to give you the same value. So all of that, I don't need to work it out again. I can see it's going to be exactly the same. Okay, so now we have the speed for A and B after the collision. So for the second part of the question, we're given that E is equal to a half. So we're actually only given the value of E here for the second part of the question. And we want to find the angle between the directions of motion. And we want to prove that that is going to be equal to tan inverse of 4 over 3. Okay, so we're going to use our velocities here to work out what our angles are after the collision. In order to do that, what we need to do is work out what is tan. So part 2, we have to remember that our slope is equal to tan of the angle. So therefore for A, we said the velocity was given by minus u over 2 root 2 in the I direction plus u over root 2 in the j direction. So therefore its slope is equal to our j over our I, and therefore we end up with a value of 2. Now, of course, this is a negative value, so in terms of slope direction, there should be a minus there. We can see obviously that that would be an obtuse, and again, if we were to sketch a diagram of that, well, we can see that we would expect B1 to bounce off with this direction here, and B2. So the angle between the two directions is what we're looking for, so that's theta. So if B2 has an angle there of beta, then this one here is the angle alpha. So we can clearly see that that's an obtuse angle. And then if we do the same for B, well, B has u over 2 root 2 I plus u over root 2 j. So then that would give us tan beta. So therefore we have u, our j vector, over our I vector. If I turn them upside down and multiply, that leaves me with 2. So essentially what we have is the same angle in both directions, just one is acute and one is obtuse. So you could also draw that diagram like so, where we have theta, and these two angles here then would actually be the same. Okay, so now I have my two slopes. What I'm going to do is find the angle between the two lines. Now the angle between the two lines is basically alpha minus beta. So in other words, the difference between those two angles there. And of course, that's our compound angle formula for tan. So therefore, that's going to be given by plus or minus m1 minus m2 over 1 plus m1 m2. So if I sub in my values there, that's going to give me tan theta is equal to plus or minus m1 minus m2 over 1 plus m1 m2, and that gives me minus 4 over 3. And of course, that's going to be tan inverse then of 4 over 3. So obviously we can have plus of minus 4 over 3, which would be minus 4 over 3. or minus of minus 4 over 3, which is 4 over 3. And if I get tan inverse, so tan beta equals 2 there. If I get tan inverse of 2, we end up with 63.43 degrees. So if I was to double that, that's 126 degrees. So these two angles here would combine to give you approximately 126.87 degrees, which means this angle here has to be acute. So therefore, that's why we're taking theta to be tan inverse of 4 over 3 rather than tan inverse minus 4 over 3, because we're looking for the acute angle. And that's what they wanted us to show as well. Okay, so where were our marks going for in this question? Well, we got 5 marks for proving it and 5 marks for setting up our formula. So our difference between angle between two lines. We then had, if I go back to the previous page, we had to get speed A and speed B. So for getting the two speeds out was 5. So I had to get both of them out to get the full 5 marks. Then we had V1 and V2, so we were getting 5 marks for the two values of P and Q. And then we had 5 marks for our two equations. So for our Newton's experimental law of restitution and for principle of conservation of momentum. So it was for both of those. So we had 5, 10, 15, and 25 in total for the question. So if we go back to the start, so we say it's 25 marks. Okay, so you should be spending just under kind of 12 minutes doing your question.